carbon has a valence electron of 4, and then oxygen has 6. So in total, I have 4 plus 6, but there's two oxygens, so that's 6 by 2, which means 6 by 2 is 12, plus 4 is 16. So I need to have a total of 16 dots on my Lewis dot diagram. Now you have to decide how to position your atoms and how they bond to each other. You have to pick a central atom. Your central atom is the one that is less electronegative, which means electronegative has to do with how much it prefers electrons. The one that prefers electrons less, you put it in the middle, and then everything else goes around it. Electronegativity increases from left to right, which means the ones on the left don't really want electrons, the ones on the right really do like electrons. Have a read of the notes and also the practice questions that we've done before. So just flick back through your tutoring book. We did those practice questions together, and then I got you to write out those short answers and get feedback on that. But just as like a general trick for how to remember electronegativity, the ones on the left really like to get rid of their electrons because it's like sodium prefers to have a positive charge. The ones on the right, like fluorine, really like to have a negative charge. So the ones on the right really like electrons. The ones on the left really don't like electrons. So electronegativity increases from left to right. Now, the other thing is oxygen's just one of those electronegative atoms that you just need to know. Okay, so oxygen's really electronegative. So carbon is going to be less electronegative. It's further to the left. Oxygen is further to the right. So carbon's going to be the one I put in the middle, followed by oxygen's on the outside. Okay, now if you don't remember that you need to put your electropositive one in the middle, you can just think of it in terms of how much is there more of? I want to put that around instead of putting in the middle. So CO2, there's 2 oxygens. It just makes sense for me to have carbon in the middle and then the same elements on the outside. Yeah, it's the same as if I had, let's say I had like CCl4, okay? You don't even need to know that carbon's more electropositive. There's 4 chlorines that I need to add. It makes sense for me to have my chlorine surrounding and my carbons in the middle. So you can think of it that way as well. Okay, so first things first, 2 dots between my atoms to represent my bonds. I've taken 4 dots now, and then I need to put the rest of my dots around. I can pick oxygen or carbon. I'm going to put it around my more electronegative atom first because it prefers electrons. And then if I have any left over, then I'll put it on my carbon. Okay, so I have 2, 4, 6, 8, 10, 12, 14, 16, and that's it. Okay, I've met my valence electron count now. So that's 2, 4, 6, 8, 10, 12, 14, 16. I'm not done yet though, okay? You want to make sure that your Lewis dot diagram, this is your Lewis dot diagram, does not disobey the octet rule. The octet rule says that you can have a maximum of 8 valence electrons. The octet rule breaks down for larger atoms because they're big enough that they can fit in more electrons, but most of the Lewis dot diagrams you're going to do, they tend to have a maximum of 8. Okay, so you want to make sure you're not disobeying your octet rule. Right now I'm not. There's 8 around this one, there's 8 around this one, and then the carbon, there's 4 around it. So that's all good. I have to have a maximum of 8. Now, I want to satisfy the octet rule, but I also want to minimize formal charge. Okay, we'll talk about what formal charge is in a second. You satisfy the octet rule. If you've satisfied the octet rule, you want to minimize your formal charge. But you do not want to violate the octet rule as you try to minimize your formal charge. So when you first finish putting the bonds in and then the rest of the electrons in, make sure it fits the octet rule. If it fits the octet rule, you can start moving your electron pairs around to try to minimize formal charge. However, if you move your pairs around and then all of a sudden the octet rule gets violated, it doesn't matter if your formal charge is minimized, you need to move your electrons back. You cannot disobey your octet rule. Once again, the step-by-step of your Lewis dot diagram, like literally step-by-step 1, 2, 3, 4, has been written out for you in your notes. So have a look at that if you need to. The way you calculate formal charge is this. The formal The formal equation for formal charge, the formal equation for formal charge is the number of valence electrons minus the number of electrons in a lone pair, which means it's not bonded to anything else, minus the number of electrons in a bonded pair, which means between two atoms, divided by 2. So I've given you the formal equation to calculate it. It's kind of annoying, think of it in terms of the formal equation, because you can technically figure out formal charge relatively quickly, but written that out for you, because sometimes when you get confused about doing it quickly, the equation's nice to have at first. Yeah. So I'm going to apply the equation first. There's a formal charge that you can assign to each of the atoms. So having a look at oxygen, first of all, the valence electron of that is 6. We figured that out from your periodic table. So that's 6 minus the number of electrons in a lone pair, 2, 4, 6. They're not bonded to anything, so that's 6. Minus the number of electrons in a bonded pair divided by 2. There's 2 bonded with carbon, so that's 2 divided by 2. Gives me 6 minus 6 is 0, minus 1 is minus 1. So the formal charge of oxygen is minus 1, and then you can do the same to the other ones. The easier way of looking at it, though, the equation is actually not that difficult, but you can apply it a lot quicker. So, let me just get rid of that. The easier way of looking at it is just going number of valence electrons 6 minus the electrons around the atom. And then when you do that, you can think of it in terms of when there's electrons between two atoms, one of them goes to one atom, the other one goes to the other atom. So these ones I put to oxygen immediately just because it's not bonded to anything else. And then the 2 that's between oxygen and carbon, I give 1 to oxygen, I give 1 to carbon. Yeah, so when it's in a pair, distribute it between the 2 atoms, otherwise it just belongs to that atom. So then draw that circle and then just count how many dots there are. 1, 2, 3, 4, 5, 6, and 7. So 6 minus 7 will give me -1. And then similarly, if I do the same thing for carbon, carbon has a valence electron of 4, because I looked at the periodic table when we did the electron count earlier. And then when I draw this out, it'll be like this, because remember, when it's between two atoms, one of them goes to the other, one of them goes to me. Yeah, so that's 4 minus 2 gives me 2. And then similarly, this one here is going to be 6 minus 7 gives me -1. Okay, so that's the formal charge at the moment. I want to get the formal charge as close to 0 as possible without violating my octet rule. That's my job when I'm drawing my Lewis dot diagram. So what I can do here is I can start moving my electron pairs around to try and get a formal charge of 0 without disobeying my octet rule. I can start moving pairs around to form double bonds or to form triple bonds. So what I'm going to do is I'll move this one over here. Just a trial and error kind of thing. And then I also want to move this one over here. Okay, so what's going to happen is this transforms into, I've moved the second pair in. So now that there's 2 electron pairs, that's actually a double bond. I'll move this one as well. And that's my new one, yeah? So I'm going to check it again. I'm going to check, first of all, I haven't disobeyed my octet rule because there's 8 around that one. There's 8 around this one. And then carbon, there's also 8 around that. So I've pushed my octet rule as far as I can go, but I haven't exceeded it, okay? So that's the point. So in this case, check my formal charge. It's easier to just draw the circle. So I cover these 2 because it's just directly on my oxygen. And then these 4, I split into 2. 2 goes with oxygen, 2 goes with carbon. So now my formal charge is valence electron 6 minus the electrons around oxygen is 6, gives me 0. And then for this one, Same thing, draw my circle around for the electrons that's actually in the proximity of oxygen. That's 6 minus 6 gives me 0 as well. And then I look at the carbon. Once again, half goes with oxygen, half goes with carbon. That's 4 minus 4 gives me 0. Okay, so that's all the steps for the Lewis dot diagram.